Alrighty, folks, let's take a look at this next problem. So we have 1.2.13. Use vector methods to prove that the diagonals of a parallelogram are orthogonal if and only if the parallelogram is a rhombus meaning that all edge lengths are the same. So it's a parallelogram that has all the same edge lengths. Okay, what we're going to find is for this exercise, it's actually easier, I think easiest, to use a result that we got from a previous exercise, which is 1.2.10. If we use the result from 1.2.10, we'll find that we can actually solve this problem readily. So just to refresh our memory, well, first let's take a look at what this is asking us. So if I draw a parallelogram here, let's draw a parallelogram. Let's say this is edge vertex A, B, C, and D. Let me try my best to connect that. And connect that. Okay. What this is saying is it's saying, look, we want you to show that this edge will have the same length as that edge, the same length as that edge, the same length as that edge, if and only if. The only way this is going to happen is if this diagonal forms a right angle with that diagonal. In other words, they're perpendicular. That means the same thing. Whenever these are perpendicular, these will have the same length, and whenever these have the same length, these will be perpendicular. That's what we want to show. We want to show that. How are we going to do that? Okay, first, well, let's do this. Let's first apply our little trick. Here's what we're going to do. We are going to first cut out that half of the diagonal and instead sort of glorify it, give it a privileged position, and call it V. We're going to do some stuff with it, so we're going to need to refer to it and think of it sort of distinct from the rest of the diagonal. So this half of the diagonal we're going to call V. And this half of this diagonal, we're going to make it point up in this direction. We're going to call that U. Okay? And now watch what happens. If I take U and I translate it down this way, so it's right here at the tail of V. I'm going to put it right here, and let me just kind of get rid of some of these. Right? And then I take V and I translate it so that it comes up here. Let me do this a little better. Okay, we end up with this shape right here. And what you can necessarily derive from this is that this has to be a parallelogram because that's just V, so that's parallel. That was just U, and that's U, so that's parallel. So this is necessarily a parallelogram. Okay, so we have a parallelogram here, and what we know is that, okay, this is V plus U, so this is V plus U right here. Well, let me write it up here in anticipation of the next thing. So this diagonal of this parallelogram is V plus U, and this diagonal is V minus U, right? Because this is V, this was U, so going from here to here, if I think of it in this direction, this is V minus U, right? So this one's V plus U, this one's V minus U. What am I going to do with this? Why did we do this? Why are we drawing this half diagonal on this one? Here's why. If you remember from exercise 1.2.10, what did 1.2.10 tell us? It told us that, okay, if you have a parallelogram, let me do it this way, so I'm going to need to extend this out a little bit. My mistake. This is U. If we have a parallelogram like this, say, then what we know about this is that this will be a rectangle. So this isn't quite a parallelogram, but we can live with it. We'll survive. This is a rectangle, meaning that the angle here would be 90 degrees if and only if this diagonal has the same length as that diagonal, right? So whenever you have a parallelogram and you know that the diagonals have the same length, then you know that this is a rectangle, meaning that this angle would be 90 degrees, and vice versa. If you know this is 90 degrees, then you know that that edge length, that diagonal length has the same length as that diagonal length. So what do I do with that? How do we apply that here? Well, if you'll notice, it's not hard to show. So if you feel a little shaky on this, take this as an additional exercise. I'm not sure, maybe it's actually in the book as well before. But you can very easily show that if this is u here, then this has to be negative u, because this is a parallelogram. So since it's a parallelogram, you know that the other half of this is just going to be the same as this one, just in the other direction, right? So the opposite direction. That's going to be a negative u. And look what we've got. We've got a parallelogram here, and we know from our previous exercise that this equaling this in length happens if and only if this forms a right angle with that. So let's write that down algebraically. So the norm of v, let me say by exercise 1.2.10, the norm of this one, v plus u, equals to the norm of that one, v minus u, if and only if what? Remember, if this is perpendicular with that, meaning that v dotted with u would be equal to 0. And what we're going to find is it's actually the end of the proof. That's good enough, because take a look at this. Take a look at this. What would it mean for v dotted u to be equal to 0? It would mean these diagonals are perpendicular, which is what we're going to want to show. We want to show that the diagonals are orthogonal, meaning they're perpendicular, right? If and only if this was the same length as that. But let's take a look at these diagonals. Well, look, already this v plus u right here, we're saying that it has the same length as this v minus u. But look, this one right here is going to be v minus u, because this is just v plus negative u is v minus u, gives us this one right here. And of course, this edge is the same as that edge, and this edge is the same as that edge, right? So if this edge equals this edge, then it follows that that equals this edge, and they all have the same edge lengths, right? Okay, yeah, so that was actually it. That was the completion of the proof. Sometimes it's helpful to kind of take some of your previous results and sort of repurpose them for new things, right? That's a lot of what we do in math, okay? All right, I hope you enjoyed it. I'll see you next time.